Let's see our first topic, Faraday's law. There are mainly two laws. The first law states that whenever a coil is associated with varying magnetic flux, an EMF is induced. Second law states that the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. When the magnet is introduced into the coil, the galvanometer shows a positive deflection. When the magnet is stationary, the galvanometer shows a zero deflection. When the magnet is removed from the coil, the galvanometer shows a negative deflection. Now let's see in the slow motion. When the magnet is removed from the coil, the galvanometer shows a negative deflection. When the magnet is stationary, the galvanometer shows a zero deflection. When the magnet is introduced into the coil, the galvanometer shows a positive deflection. Lenz's law states that the polarity of the induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produces it.
Lenz's law, a consequence of conservation of energy.
As the magnet is introduced inside the coil with north polarity pointing towards the coil induces a north polarity which causes a reflection. Therefore, we have to do mechanical work. When the magnet is removed from the coil induces a south polarity which attracts the magnet. Therefore, we have to do a mechanical work. This mechanical work is converted into electrical energy and then dissipated as heat in the loop by Joule heating produced by the induced current.
Eddy currents. Whenever a solid conductor is associated with a varying magnetic field, induced EMF is produced in forms of eddies. This phenomenon was explained by physicist Foucault, and these currents are called eddy currents. Consider the experiment. An aluminum plate is allowed to swing between the pole pieces of the magnet. We can see that the motion is damped in a little while. This phenomenon can be explained in terms of electromagnetic induction. Magnetic flux associated with the plate keeps on changing as the plate moves in and out of the polar pieces. The flux change induces eddy currents in the plate. Direction of eddy currents are opposite when it moves in and out of the pole pieces. In this case, the area available for the flow of eddy currents is less. Hence, the plate with holes or slots moves more freely between the pole pieces.
Transformer consists of primary coil and secondary coil. Is a device which converts high voltage to low voltage or low voltage to high voltage. Step-up transformer. Step-up transformer converts low voltage to high voltage. The primary coil is thick and has less number of turns of coil. and the secondary coil has more number of turns of coil, and therefore the output voltage is more. Step-down transformer. Step-down transformer converts high voltage to low voltage. And in this one, the secondary coil is thick and has less number of turns of coil, and the primary coil has more number of turns of coil, and therefore the output voltage is less.
Hope you guys understand what we try to explain. If you like the video, hit the thumbs up button and subscribe for more.
If you have any doubt or want to know more about this video, please comment below so that we can reply you with the most comfortable answer.